Thank you very much, Ms. Ananda Viswanath, for introducing me to the audience. And good afternoon to all of you. I think it's a pleasure to see that this group, gathering here we are facing a lot of troubles at the moment. So under that circumstances, also you are interested, have a very nice dialogue on engineering education in Sri Lanka. Anyway, I must thank Society of Civil Engineers, Society of Structural Engineers Sri Lanka to inviting me to deliver this question time talk. Right, I think I made a few talk before in question times. I specifically, presenting a special topic, which is discussing about some of the aspects of our engineering practice. But today, I do want to change the topic and discuss a little bit of a broader topic, and which include the education, new technologies, and opportunities in challenging working environment. I think probably you might heard about the book called 21 Lessons by Professor Harari. Some of you might heard about it. And he said in the book, and he's asking from the readers that question that, do you think that the history professors, when they get together, they all discuss about what could be the reason for the Second World War and how to prevent the Third World War, something like that? He said, no, they just discuss the gossip. Similarly, here, we will have the gossip discussions in the proper time. I think one of my friend is commenting that, it's not good to have a dinner after the talk, that we are very, very interested about Apaka stories. Anyway, with that note, I would like to start. We'll have a fruitful discussion. This is not just one person is talking to you. I think you can stop me at any time. We'll have a good discussion how to change this environment, at least for the next generation, at least to create something for the next generation. So then, education. Let me to go ahead with the evolution of engineering education in Sri Lanka. It's very important. Probably you might think that this is too much at this crisis to discuss about the evolution of engineering education in Sri Lanka. Right? Anyway, you might know that in 1942, it's a very important year for us. In 1942, there are two incidents happened. The one is University of London offered our Sri Lankan students to get the external BSc engineering degree incorporated with Ceylon Technical College. That is the first time our students exposed to an engineering degree program. It happened in 1942. The second incident is in 1942, University of Ceylon was established. That is the second major thing happened. Right in and once 1942, University of Ceylon was established, and then the discussions was happened. Okay, how do you establish the engineering faculty under the University of Ceylon? Somehow, in 1950, the first engineering faculty was established. That was in Colombo, in the premises of Ceylon Technical College. And later, in 1964, it was transferred to the current location at University of Peradeniya. So this is how University of Peradeniya was established, and that is how the engineering education was established in the country. And do you believe that when in 1950, this project was assigned to the Professor E.O.E. Pereira by the Cybergenies. Okay, design a university, design a faculty and give me the proposal. So under the Professor E.O.E. Pereira, he has studied it and he gave a proposal of 10 million worth project to establish the engineering faculty at Peradeniya. 425 students can be accommodated according to this plan. And that was rejected by Professor, or rejected by the cabinet, as well as by the Zygogenes. And Zygogenes write to the Professor Eopera saying that I have money for only 25 students. I can accommodate only 25 students. I have allocated only 3 million rupees for this project. Somehow, with a visionary person, he has changed attitude of cabinet. He has changed attitude of the Zygogenes, and finally, he was able to set up engineering faculty at Peradeniya for 125 students. Do you believe that his vision in 1964, when the Peradeniya, engineering faculty started at Peradeniya, the number of students was 150. The first batch, or inaugural batch, in 1950 at Colombo is 25 students. Now, this is how this engineering education was established in the country. And then look at the current figures. So we have now 6 engineering faculties. We produce nearly 2,500 engineers annually. And if you look at the numbers, you look at that, those who selected for a universities, only 6% goes to the engineering degree program. Only 6%, even in the 6 engineering faculties. And then in the past, this curriculum was established after 1971. Right, before 1971, there was not the final part 3 examination, only part 1 and part 2 with the first examination of engineering. Before 1971. After the 1971, this is the curriculum. Right, I think some of you already, I think many senior engineers are there, so you have followed this program. The first examination in engineering, final part 1 examination in engineering, and a specialization program comes with the 2 parts, part 2 and part 3. Very importantly, in this year, in 1971, they introduced a good concept called course A, course B. The course B is for, now you can see that, how the visionary group of people who established the engineering education in the country. And they said, the course B is for absorbing new knowledge and introduce it to the engineering community. While course A is standard courses. Very interesting. See that in 1971, right, people thought that engineering curriculum should be dynamic. It should not be static one and should not be very rigid. It should be flexible. With the new knowledge comes, it should be absorbed by the engineering curriculum. And then only the new knowledge can be transferred to the industry through the engineering education. Very interesting. This was happened, that we call B course. And later, this is what we are presenting, teaching to our engineering students. Many changes happen. Now, we have a compulsory subject first year. In some engineering faculties might be, following same format in slightly different way. Probably their general program duration might be different. But if you look at overall wise, we have a certain common way of delivery. So we have a compulsory courses, a certain period, and then come to the specialization program. We have a core courses. We have technical elective courses. We have general elective courses, and the industrial training phase is there. And also, the civil engineering research project was introduced. I see 3 major changes happen during last 75 years. Now, Peradeniya next year, Peradeniya is celebrating its 75th anniversary. It was established in 1950. Now, 2025, we are celebrating the 75th. During this 75th years of education in the country, in engineering education in the country, I see 3 major changes happen. The first major change, to introduce the B courses. Because you make the rigid curriculum to a flexible curriculum and absorb new knowledge. These B courses later change the name of called technical electives. So we give the students to freedom, choose some of the courses according to students' choice, students' preferences. We are not saying students to go in this path. No, you can choose. Once you get a basic knowledge on engineering,
you can choose the path you would like to prefer or develop your career in the future. So technical electives, I see one of the major important component, and also research project. These are the two places we can see that major changes happen. The B courses, introduction of B courses is one of the major change. And the second one, we change from year systems to a semester system. Year system to a semester system. I'm not going to discuss too much on it. There are pros and cons, and we have a debate whether it's a good move or right move or whatever. But the third move, our degree program is accredited by the international body or Washington Accord, whatever. So that is another move that was happening in 2014 at Peradeniya. Right? So it's very important to know that our degree is accredited by the foreign agencies or foreign body. So then our engineers are able to work in a global platform. So at this moment, our engineers should be able to, I will discuss in the future. So you should change your mind, you should change your attitude, you should work in the global platform. We are not working in any local institution or local area. We have to work on the global platform. That is where the way out. So I will come to that discussion. How to move into the slowly. Right. This is outcome. This is the present outcome according to the data. These are the past 5 years of data, but I will be a little biased to the Peradeniya. Right. If you look at carefully, 150 students who graduated from the Peradeniya. So I have listed some major areas. Like we have a local construction industry, international construction industry, the local academia and international academia, and then the local design firms and international design firms, and outside area of civil engineering, finance sector, banking sector, or government services and etc. So now you can see roughly numbers. What is our distribution? And these are correct data gathered from our past students. This is how the distribution. Now see where we are lacking. You can clearly see that we are not producing the engineers to meet the international targets. Right? We are giving very international construction industry very 5%. It's quite small, and international design firms almost nothing. I'm not asking the engineers to go abroad and leave the country and settle there in outside. No, you can go and work those companies, and you can grab the opportunity. This part of it you can bring back to Sri Lanka, and you can make the startups. Right? This is happening at individual level, but we need to set up a systems to. This is going to be our common working area. So that is why I present this information to you. Right? Opportunities. Now we produce. I think you have seen that we have a very established two academia group, as well as we have the well-established industry. Compared to the many other disciplines of engineering, the civil engineering has everything. So we have the complete industry. Unfortunately, we are facing a big issue at the moment, but we had, or you can say we are having the a complete industry. But unfortunately, what happened in the country? We are well separated. The academia in academic field and the industry thinks that academics knows, I'm sorry, the senior engineers are here, knows only the theory part. They are lacking in practice. And academics thinks that our job is to produce engineers. Teaching is number one. Fine, great. We are in two separate ways. And in here and there, the few people might cross the boundaries. We have seen that. But where is our system? We need to set up a mechanisms. This happens naturally. We can't keep the two separate. Then there is no blooming in the industry. There is no development in the country. As I said, in 1971, we thought about introducing the new technology into the industry to the curricula. That is why the courses came out. But where is that concept? At the present, we are well separated. Our links, Academia industry links are too weak, except few people crosses these boundaries. So we want to have mechanisms to cross these boundaries, make this is a unique one. This is where the more opportunity created. As long as we are separated, we are not creating the opportunity which might take into, which might able to address the international industry. That is very, very, very important as far as I concerned. Right. These are the challenges, I would say, for future civil engineers. For you, many of the people who are in below 40, you have to face this challenge, I'm pretty sure. To work on a global platform, you have to work on a global platform. You have to change your attitude. I might see, sometimes I talk to the young engineers who just graduated and they might looking for a job in water board. If anybody from water board don't mind me, I mean, our fresh graduate might be, joining water board, and you make sure there's a government job, fixed salary is coming. You can slowly climb up the ladder and you can achieve some other positions. Anyway, they are very happy with that, going with that, very standard, I would say the lethargic way. Because that is more secure. They are not trained to take the risk, right? They need to change attitude. I mean, how many of you in water board now live in the place? How many of you are in RDA live in the place? How many of you in CCB live in the place? Why this is happening? Yes, we know that. We are lacking in our projects. We are lacking in the funding. We are lacking in, we are not sure whether our future, in the future, we'll get the salary. We know the environment create so uncertain situations. Why this has happened? Because we are not trained to work on the global platform. You have to change attitude. It is not just to do a day-to-day work, right? And third thing, adopt the new technology. Technology is in the practice, in practice. That is very, very, very important. If you don't adapt the new technology, we are going away from the global platform. We'll be isolated. Then we are looking for that ordinary jobs. But if you adopt the new technology, I'm pretty sure that you create opportunities. This is where the opportunities come. In the future, I mentioned that 21 lessons book. In the future, ordinary civil engineer might not be required. Ordinary architect might not be the society is expecting. The society might need somebody else. The somebody else should need certain skills. What are the skills we are looking for there? And those create actually new opportunities. So we have to train our next generations to understand the situations and they learn accordingly, right? And third thing is to practice multidisciplinary engineering. Very, very, very important again. I mean, if you're isolated in one particular area, you might not create so many opportunities. But it doesn't mean that we don't need experts. Yes, we need experts than before, right? We need the expert, but the expert should be able to work in the multidisciplinary nature. So we need to practice multidisciplinary engineering. So my talk, the rest of the part will be based on these three aspects. Let's go in the global platform. We started when the engineering faculty was established in 1950. There is a reason for, they started the engineering faculty for 25 students. Yes, in 1950, just 2 years after the, end in the British era or independent from the British government. They might think 25 engineers is adequate to maintain the system they have established. Fortunately, we had the people like Prof. Pera. He had a vision that this country will develop in the future, in the near future. The additional engineers are required. That is why he set up the Peradeniya for 125 students. Now we have expanded it almost out 2,500 students. We have expanded that facility for the development of a country. Now, if you look at our Sri Lanka itself, right? If you think that, I forgot to mention you that we have a more than that number, 2,500. I mean, the students who are working in a private colleges or private universities, the number might be double there. Right? This number of engineers we are producing to work within Sri Lankan context, it's too much. That's why some people are too much. We are producing too much of engineers. I'm not saying that too much of engineers in the sense that if you think about, we produce to just development of Sri Lanka itself, yes, then we are producing too much. It's not the case. We should be able to produce more than that and capture the global platform. I have said that we need to work in the global platform. If you don't work in the global platform, your engineering practice is going to be dying day by day. Because if you work in the global platform, you create new opportunities, we are creating a network. We take a part of the big project, bring it to Sri Lanka. That contribute to our economy. Right? This networking is very, very important. Right? I think many of the senior engineers who have done that and who start up and you have practice and you have firms probably working in the international projects. You bring a part of the project. And this is how the, engineering practice should be in the future. So therefore, at the beginning, we start working in the local area, one engineer who look after all the services and everything and who want to build something, and one or two engineers who might work in the town and he's looking after everything. And meantime, when the development happens, you need to work in a many projects around the country or in the different cities. And you have to have a network. You expand your area. But today, we have to work in the global. Right? Our project might be happening in a few countries around, and we are working from Sri Lanka. This is the attitude change I think we need as engineers. Right? And then the adapting new technology. I think you all agree with me that 5 stages of a civil engineering project, probably I might miss one or two component. No, what do you think? You all agree with that? Pre-design phase. Pre-design phase, and then the pre-construction stage, the procurement part, and then the construction and the post-construction. Probably you might think that handing over the job and so on and will be the part of the post-construction phase. But I go a little bit beyond that and looking at the overall project. You all agree with me? Now this is not happening at the moment in the country, but this is what we have done. Like if you go for the pre-design phase, you might need some information, right? You might do the ground survey, and you might do a preliminary design, preliminary investigations, and soil investigations, and you might discuss about the feasibility of a project, and all these things happening in the pre-design phase. And when you come to the analysis and design phase, I call it pre-construction phase, you do a detailed design, right? You use your knowledge on finite element method or structural analysis, and you have, first you set up the nice architectural drawings, and based on that, you design the superstructure and substructural component, and then you design them and you size them and you provide the reinforcement, and finally you produce them in a drawing, set of drawings. Right? This is happening. And once you give the drawings and you know that the procurement part, you need to handle all the resources well. And then you put that into a construction, and I don't need to explain this, I will be very short. And then we go for the post-construction phase and we maintain the system. And if the repairing is required or retrofitting is required, we take a decision accordingly. Now, do you believe that in 10, 15 years, this entire process will be handled by a software? I'm sorry that senior engineers might not agree with me. This entire process will be handled by the software. Then you have to get the charter for the software, not the individual member charter. There will not be chartered engineers, but there will be chartered softwares. I'm sorry that, I'm talking the ESL, right? I'll be in trouble, right? Yeah, yeah. So we need at least, in this process, the things are happening here and there. At the level, now it already comes. You need to integrate everything together and produce by one software. I will explain how it happens. Now, first part. Do you think that we need any longer, what do you call, theodolite is already gone. What is next? Total stations. Do you think we need a total station in the future? No need. Drone technology together with LiDAR systems easily generate the ground profile. It's already happening. Remember, many companies are now setting up to develop this part. These are the new opportunities that was not there before. It is a part of survey. Do you think that the future of the survey? Right? Somebody might say that the grass cover is an issue of taking the ground profile. No, now new technology with the LiDAR system that can be penetrated to the ground, and you can get the ground profile easily. The technology has upgraded, has developed to overcome some of the barriers nowadays. Now, very nicely, you can get it large area contour map within a short period of time. And your drone will set up the path, and he will follow the path and give you the data set. You have a software, you can produce the ground contour map directly. And next, subsoil investigation through the drone using the GPR, ground penetration radar. With the gamma radar also, this has been further strengthening. So now you can get the subsoil contour. You need geotechnical investigations and digging these boreholes. And you can get the entire picture of the entire area. Where the subsoil layers are, how the layers are distributed, where the bedrock, and every information will be given. Geotechnical engineers will be in trouble in the future. I'm sorry to say that. We'll be in trouble in the future. But where the opportunity comes, you train to adapt the new technology, your basic geotechnical engineering knowledge can be integrated with this, and you can do a wonderful job. The basics are basics everywhere. It won't die. But adapting new technology together with the basic, you can do wonders. This is what we need to understand. Okay, I said that is the preliminary part. What will happen in the other parts? I will explain that how the entire process controlled by a software. Now, first part, we'll go for analysis and design. At the moment, what is the problem of finite element software? I mean, say, you know finite element theory well, and you know how to handle it very well, right? I mean, don't say that, somebody person who doesn't know finite element well, and is trying to develop a model, you might call it garbage in, garbage out. No, we'll forget that. The person who is capable to handle finite element software, what is the issue? The issue is the intelligence. Issue is the intelligence. Now, finite element software will be integrated with the machine learning technique or artificial intelligence techniques. The knowledge, intelligence will be added to the finite element method. Now, what will happen next generation? What will happen in the next generations? The software will acquire the data from topography. Software will acquire the data from the subsoil investigation, and intelligence added to the finite element or architectural drawings. You go to a software, you say that I need this one, I need that one, I need this one. You just talk to the computer, and computer will place them and produce a nice structural, architectural drawings. You tell him a requirement, he will produce a drawing to you. Is it possible? Do you think that is impossible? Now you tell your requirement. You tell your requirement, I need a bathroom in this floor, I need a bedroom in this side, and you are given the land area to a software. He will prepare a good set of drawings if the intelligence is added. Then now you need architect. Why? The intelligence is not there. Architect cover the intelligence part. The structural engineer cover the intelligence part. That is why finite element software itself cannot do anything. But once you add the intelligence through these AI techniques, no longer required. What will happen? Okay, software, such intelligence added software, what will do? It will take the data from ground survey, data from the, what you call, geotechnical investigation, and you talk to the software will produce architectural drawings to you, and then based on the architectural drawing, software will decide where the column positions and how the column beam arrangement, how do I optimize it, and even software will decide which location I need to place the foundations once the intelligence is added. The software will decide the foundation location, foundation type, and then the structural arrangement, and then finite element software will produce finite element analysis. Based on the analysis, design will be done in the software itself, and finally produce the set of drawings. You don't need the client go to the computer, he speaks to the computer, he produces a set of structural drawing within a very short period of time with a good accuracy. Once you develop a good software. Do you think that this is something crazy? Do you think that this is something crazy? Perhaps any graduate might crazy, you know. Yeah. This is not going to be crazy in the future. Right? Next stage. This set of drawings will go to the 3D printer. This set of drawings will go to the 3D printer. The 3D printer will start constructing your house or constructing your building. That is what it's called. In a 3D printing, conventional construction technology will be disappeared. But you need to do these operations, you need new material. Conventional reinforced concrete will not be will be issue. So new material is required for this operation, 3D printing operations. I mean, you can't bind the reinforcement there. So you have to have a material should be taken into account those forces and stresses. The new material should be generated. And the new material is already developed. The fiber reinforced concrete and ultra high performance fiber reinforced concrete that will match with the 3D printing operations. In Switzerland and in even Malaysia, even very rarely it happens a new construct with the typical reinforced concrete. Everything will be replaced by the fiber reinforced concrete. Do you know in Sri Lanka also we started using fiber reinforced concrete? Do you know any project going on in Sri Lanka? I ask you to go and visit and see that new material development. The fiber reinforced concrete in Upper Alahara Channel project. That tunnel lining with the fiber reinforced concrete. It's already started happening. All right. The ultra high performance is one of the next generation. I mean, ultra high performance is not a new material, but the usage with the 3D printing technology and especially the properties of that particular material is widely now using entire outside community. I mean, if you are not well aware of this technology, it is very important. It's not possible to work in a global platform. So now you can see the 3D printing will start working. And 3D printing will build your house, build your building. Once it was built, now you have to maintain them. How do you maintain? Now, for example, if anybody from Mahaveli Authority, if you go to the Victoria Dam next visit to Victoria Dam, you see that there are more than 30 number of prisms already attached to the entire dam body. And the two robotic theodolite is measuring the dam deformation for every 3 hours. So that is happening 24/7. The deformation of the Victoria Dam are now live within 3 hours of interval. Now you get all of this data into a screen. And you have developed this SCADA system to acquire all this system. And you take the decision. You take the decision based on the outcome you get from the SCADA system. So you have data, massive amount of data. Now you know that what are the threshold limits. The threshold limits will be set up. If the settlement happens, right, the knowledge is created, okay, in this particular building, this is the threshold limit of the settlement. If you exceed that, you get the warning. You do a required precautions. Now this setup is completely automatic. But important thing is that you should know the threshold limits. If you know the threshold limits, softwares can give you the warning. Okay, these are the, if you check at the deflection of the important members, you set up a certain sensor will feed this SCADA system and display, and you will have all of information. Once you know the threshold limits, you are done. But as I ask usually from Marvel Authority, okay, you have data of 3-hour data in 24/7. What you will do? What will do? Huh? Yeah, exactly. I mean, you might know that what are the threshold limit of the displacement of a dam in certain locations. And once you exact, and you can write a little program, and if any of the deformation component exceed the threshold limit, you are giving the warning. Then you can take the immediate precautions, and you can decide whether you have to need some sort of repairing or some sort of it. You can do that. You know that entire process will be automatic, will be handled by a software. Do you think that it is too far? Now you see, 3D printing is happening in one side. The material development is happening, and SCADA system already developed. The finite element model is replaced by the BIM modeling. Now, many of you are working in the international arena. You know that how important the BIM modeling. Right? Once you add the intelligence, what is called machine learning model or AI model to the BIM, done. Unfortunately, we have two ways to do that. One way, you stop. You stop development of machine learning, artificial intelligence. You are not allowed to incorporate with the BIM, and we keep our ordinary job safe. It is into a certain extent happening. Another way that you adapt this knowledge and you develop, you create a new knowledge with the BIM and you develop your own software. And you can sell that software. Your software will get the charter because you have to test the performance. Get the chartership of your software and you earn money. I mean, these are the new opportunity, I would say. So very, very important to understand this, right? I mean, you can see that things happening here and there. Things happening here and there. But now, in the next generation, what will happen? Everything will be incorporated together into one platform. That is what is not happened yet. Integrating all these things into one platform. Once it is done, remember, there will be thousands of other jobs will be created. You should be ready for it. If any of you planning to leave the country, I mean, younger generation, I can't say that you don't leave the country, but any of you plan to leave the country or do a master's, do a PhD, think about this platform. Engage in one of these components and grab the opportunity, and you develop the skill. You will be a very potential candidate in the future working in a global platform. Doesn't matter you are in Saudi Arabia or Sri Lanka. You can come back to Sri Lanka and you can start your own one. But I know that is happening. I recently, not few years ago, 2 years ago, not 3 years ago, I visited IIT Madras. And IIT Madras has what you call science park. I am fortunate to visit that science park, and I met 2 Indian boys, age of 26 to 27. And they are running their own business. And they said, they told me that, my annual income is huge. What they have done? They developed a algorithm, right, to detect the cracks in the reinforced concrete elements. They have the drone technology. They develop their algorithm and image capturing process. They fix their camera into the drone and scan the entire structure and get the pictures. Once you get these photos, their software will be able to detect the crack propagation, orientation of the cracks. And they get offers from all oil companies. They have the offshore tall concrete structures in their platforms. And their job is just scan them regularly and make sure that the crack propagation is not severe and limit the threshold limits. So regularly they get the job and they earn a lot of money. What they have done? They simply develop a algorithm which can capture the reinforced concrete through scanning the photos. The photos will be taken by the drone camera. I mean, these are the new opportunities. IIT graduates with the less experience, 27, 28, not more than 3-4 years experience. That one from civil engineering background, one from the electronics engineering background. The two see that couple, the fantastic outcome comes, the huge amount of money they get. And they were asking again for me, anybody from water board, the water leakage, detect the water leakage. They have developed a drone to detect the water leakage. And how many of in our system think about a remote detecting of water leakage, and we can save a lot of money? No, we won't. We are going for a more preliminary things to identify the. I mean, we are not really adopting the latest technology. Then we can do really wonders. And this is where I want to highlight the entire thing. And this is where we should think. This is where the most important the development happen in the future, near future. So everything will be auto. So this is what I want to say. I mean, some of you not. This might be a controversial statement. Anyway, please don't blame me. But chartered engineer will be replaced by a chartered software. I like that. I mean, I personally like that this should not happen, because our few generations, I invite you to read the book of 21 lessons by Professor Harari. What will happen to us in the future? This society will not controlled by in the future by the politicians. This society will control by the software developers. Believe me or not. But knowing or not knowing, you are controlled by many of the occasions by yourself. Your preferences you get once you search in something, you will get a pop-up messages saying that, okay, why don't you look for this, look for this? And you read by your mobile phone is reading you. Right? This is happening. This is happening. We need to understand. We need to understand it and take the necessary precautions. Right. Now the question is, Peradeniya University, one of the lecturer, and who is talking about, the new development, everything will be automatic. I mean, don't blame that. One of the lecturer from Peradeniya is saying that chartered engineer is no longer required. I don't do a charter. No, please don't take it. I mean, but what I want to say that, I mean, here and there, these things happening. Now the question for academic community, how to integrate new technology in undergraduate program? We need to expose our next generations to this area. Otherwise, as you know, 1971, the B courses, I feel it a genuine, very strong step taken at 1971, adopting a new technology into your curriculum. Now that is the leaders we had at that time. But what about we are doing now, right now? If we don't adopt this new technology into our curricula, what will happen? We will destroying future generations and their career. So we need to understand this way. How do you develop it? We have a two nice component setup. What is called technical elective courses and civil engineering research. These are the places. I think one of my friends is here. Shall I tell you? He did a master with me, and he made a proposal to the community, our community, how to adopt the new technology. It is in the successful level, I guess. I don't know whether I say it's a good thing to say it. No, This is one good example how the new technology will be applied to the community and make sure that we are stronger. Show them we are stronger in applying the new technology. One of the examples is already in the audience. Right. We have technical elective courses and civil engineering research projects. We have 16 credit out of 150 credit. The 16 credits are general, what you call elective courses. So we can introduce AI or machine learning techniques in one of these courses. And we can introduce them the drone technology. And we can introduce them the signal processing technique for civil engineering students. And then they know that, what is going on in, LiDAR system. They might know that, how this ground penetration radar works and define the layers. We introduce the basics through these courses. Then once you use the technology, it is not a black box for them. I mean, we are teaching finite element method. And then if you know the finite element well, together with the machine learning, you can introduce the intelligence and make your finite element model or finite element software with the intelligence. It has its own brain. How to do that? We have a data. We have designed a lot of structures, right? You know that? Then do you think that it is a very serious thing? So depending on the span and the usage, can you predict the beam depth? Once you have thousands of data, and you can optimize as well, and satisfying all the code requirements. The initial guess is the intelligence, but now we need, when you develop a finite element model, depending on the span, you have to guess what is the depth required, and then you can verify whether that depth, align with the code specific design approach, and then you design the reinforcement. But this can be done once you have a big data sets. We have designed thousands buildings with the different spans for different loading. All of them can be clustered, and software will use the cluster, bring that knowledge into the model, and sort out the problem. No, that is what I'm saying. This is not a magic. This is happening. That is happening not at the beginning level. It's happening at the end level. That is why we have to be more attention, right? So in a 16 credit course, we can introduce this artificial intelligence and machine learning technique. That is very much important in creating intelligence. And then signal processing, and through the civil engineering projects. And now many engineers are working to develop the mixed design, automatic mixed design. Already been done by one of my students for a geopolymer concrete. Geopolymer concrete has a more variability of parameters, right? Once you said, okay, this is my compressive strength. I will use this particular source of fly ash, and according to that, please give me the mixed composition. The software we have already developed for reinforced concrete, fiber reinforced concrete, and the geopolymer concrete already been done. The fiber reinforced concrete, I think we are practicing more than 150 megapascal strength. That will be one of the good material for future rest of the. Right? Now you don't need any computer or any code of practice. The software has already developed to generate the mixed design. So this has already been happened. So we can make use of these credits to introduce this new technology into the curriculum. So the Peradeniya we are having a discussions. How do I change our curriculum from elective courses where we can introduce the new courses? Then how our graduate lifted to the next generation? Right? At the beginning, I said before 1971, we have just civil engineering, general engineer. We look after our system, or look after the system developed by the British. And next, after 1971, either we don't call it specialization, we let the specializations to happen. Right? You might say that I am a civil engineer specialized in structural engineering. That is called specializing. Do you think that is enough to meet the future generation, future demand, requirement? No, not at all. The Peradeniya is now having discussions to going into major minor concept. You major in civil engineering, you minor in artificial intelligence with the specialization. So you can say that I'm a civil engineer specialize in structural engineering, and I am a minor with artificial intelligence, or signal processing, drone technology, or computational mechanics with the intelligence. I mean, we are trying to create more opportunities, more paths for undergraduate students. So they can choose those paths according to their wish. We have to have our curriculum more flexible. But remember, we are delivering the basics. Basics are basics. Differential equations are differential equations. That won't challenge by the AI. AI won't challenge your differential equations, but AI will challenge your approach. The approach is already being challenged. Right? So we need more specialization. Right? So Peradhan is having a discussions. But in our engineering community is having a discussion about 150 credit, reduced to 130. You must know that. That is why I brought this issue to engineering community and senior engineers and mid-career engineers as well as the junior engineers. Reducing it from 150 to 130, not knowing about the development in the industry, in the surrounding, you will be putting our future generation in big trouble. Please tell these things to when you go to the what do you call department industry, interactive sales, whatever, right? So when you reduce 130 credit, right, you have to have a basic knowledge that must be developed, that must be transferred, the basic knowledge. It required around 100 credit out of this 150. That has to be done. You have no way to cater that. You have to have a foundation, the very strong foundation. On the top of that, we do all other things. Right? In that case, if you reduce to 130, where do you reduce? You have to eliminate the elective courses. I know that some of the leading engineering faculties is trying to do that. I'm sorry to say. They haven't seen the future at all. I was shocked. I was shocked to reduce it. And who is now see how this country works. And ISL is the responsible body for accreditation. Right? How do you say one credit is 50 notional hours? Who said? I think we should ask ISL, how do you set one credit equivalent to 50 notional hours? Where is your research? How do you know that? If somebody used it in America or British or in Europe, we take it and plant it here. And then what happened, right? We define, I mean, our curriculum, I said, that is why I put you to a history and discuss about the evolution of engineering education, right? You see that there was no concept called credit, but the knowledge and industry outcome incorporated approach is there. So you have to have basic things. You have to have new courses. That's why I say B course. The B course open up for the new development. Then what happened? We suddenly come up with the one credit is equivalent 50. And then we calculate all the course, 3 credit, 2 credit, and count them 150. And then 150 credit multiply by 50, you have this much of hours to work. And then people identified that 24 hours is not enough to cover the requirement. So then we are saying that we are trying to teach too much to the students. We are failed. No, this is what sometimes people are commenting, but you don't know the basic. One credit equivalent to 50 notional hours. Nobody knows. Nobody has done research. Nobody has done research in our community. Right? We adopt the things sometimes blindly. Right? That is what. So then, what we really want? What we really want? Keep our 150. If you reduce to 130, we have to remove the technical electives. This is where the new technology can be embedded in the curriculum. You might miss this opportunity. That is why I'm not supporting at all to reduce 150. Keep them and give them a minor. Instead of reducing the credit, give the good student to minor. I am not saying that every student will go in structure, what do you call civil engineering, specialize in structural and mine in artificial intelligence. No. Only few number of students will go follow that path. Maybe 10% of the entire batch might go with that path. So that 10% is required for the country, while majority will go with the civil engineering and specialization. You'll end up with the middle, right? So we cater all the layers. But thing is that our curriculum should be open up for all the layers. We should not shut down any of the layer. So our new layer is you need this artificial intelligence knowledge and applications and development. Some group of people should work on it. Then only the knowledge will be transferred to the industry. That is what I want to really highlight through this, right? And this is where the other problem I want to highlight, the postgraduate program. Now I said Peradeniya is celebrating 75th anniversary next year. Unfortunately, please believe me, I don't know if you know anybody here, you can correct me. As far as I'm concerned, there is no full-time postgraduate program in the country in engineering education. There is no full-time postgraduate program. Now we are celebrating 75th year of the engineering education. No full-time postgraduate program aligned with undergraduate program. It's a very big mistake we do. You know the reasons behind it? Engineers don't know, but anybody from the academia, they might know that. The reason is that the UGC is not allowing paying for teaching in postgraduate program during the working hours. This is the barrier. This is the barrier. So we are talking about the system change and so on. And how many senior professors in this country? Have you seen anybody speaking up about it? I myself, I'm really highlighting this issue to our Peradeniya administration. Very serious. We are celebrating 75th. It is a shame on us. If you don't have, I mean, being #1 university in Sri Lanka, Peradeniya don't have a postgraduate program. How do we go into the outside world and showing our colors? No way. We are producing good graduates, and those graduates will be used by some other universities to technological development. This is what is happening. We produce engineers for outsides to go and work in the top places. And we never, I mean, Peradeniya has alumni. Have you think that Peradeniya is contacting? And India is doing it. India is doing it very smartly. See that. All IITs, Indian government produce 50 PhD scholars for each IITs every year. And good IIT student led the outside country and go and work in the MITs and all places. And once they get a job in Google, what will happen? The Indian government has a mechanisms to have an interaction with them. And you have a connections. You bring a lot of project to India. That is why IITs place the IT hub in India, right? And you might know that any vehicle brand, the factory will be in factory already established in India. Why? It is not just a market, but they know that the technology development already happened. We acquire the technology by spreading the students all over the world, and they have the network and bring that knowledge back to the India. And India has already developed the technology platform through the networking. But we are just produce them and let them time to time he might come to the media and say that I am working at the Peradeniya during that time, and now I am working in NASA. And but yeah, he's working in NASA. He's a Peradeniya product. We are very proud of it. That's all. Have you ever invited him to Peradeniya and having a discussions? Shall we collaborate for some project? Can you bring, and we have a certain the knowledge is created. We have a good academics, we have a good industry, so we can interact, and you can also be a part of it, having a network and send few more students and to expand the networking. No, nothing happened. We think that we are the best. Done. Now, this is where we made a serious mistakes. These are very important. That's what I said. You need undergraduate program, postgraduate program, full-time interacted each other. very much. What are the benefits we get? The benefit, we have a split PhD program with foreign universities. We can have a joint master program with the foreign universities. And we can have an industry-university collaboration. We can have exchange program staff, foreign student staff exchange program. And we have an interdepartment, interfaculty, inter-university collaboration. All of them is possible only with a full-time postgraduate program. You can't do it the undergraduate program. And you can't do it the part-time program. I think some of you have already done a master in part-time. You know that how difficult. You are working from Monday to even Sunday, right? You're working from Monday to Friday in office, in heavy stress environment. You have to work hard. Yes, I know that. In Friday, in Saturday and Sunday, we are teaching you. You are a human, right? You have a limit to absorb the capacity. It doesn't work. Doesn't work. This part-time program doesn't work. Then we are blaming you. You are coming for this master program to get the certificate for next promotion. I'm sorry to say. You didn't do that. I'm pretty sure that. But sometimes we call it like that. So we don't take the good brains into our system and make all of these things happen. And do you think that we need to have a special treatment for developing the startups or entrepreneurs? No, I have heard about the people are discussing about the developing entrepreneurs and creating more entrepreneurs. That will make, I have seen one speech that saying that, number of, what you call entrepreneurs are, reducing day by day. We don't have entrepreneurs, only speaking. We have a business. You talk about the research project, who will want to invest for that taking the risk? That is a real entrepreneur. He will ask you at the one stage, okay, shall we apply for NRC grant for this? Rather than putting his money on this as an investment? No. We don't know really what is the culture of, what is the difference between the entrepreneur and the business. If you invest the money really through this process, and we can do a lot of industry-university collaborations, and together with all of them. Okay, what is the advantage of them? That is, I call it culture of research pyramid. This culture has to be planted in all the universities. You have undergraduate researchers, undergraduate students, master students, MPhil, PhD students, and you have a supervisory panel. All of them will be integrated. All of them will be integrated. Right? So, very nice. So we can work for a many development. Okay. Let me to quickly go through this industry-university collaboration. This is where I said we are two apart from each other. At the beginning, I said industry in one side, academia in the other side. We are not interacting well. Okay, let me go through quite fast. This is another important document. We call it Global Innovation Index, GII. This is published by the World Intellectual Property Organization, we are called WIPO, together with the Cornell University. And all the economies in the world, 136 countries were included. Their economies are ranked based on the innovation. We call it innovative economics. And these economies has been ranked based on the 7 criteria. So I will, you can see that some of the top rank innovative economies in the world, based on the different regions. I'm not going to explain. And this is where the investment happen, right? R&D expenditure in various sectors, and revenue of each sector, and then R&D intensity. You know what is the R&D intensity? You divide the R&D investment or expenditure over the revenue and multiply by 100. That is what called intensity. Now you can see, but unfortunately I don't see that the agricultural sector. That is, I was seriously questionable. But all other sectors are there. Now you can see a construction industry. So you have a research and development expenditure is quite low, but your revenue is quite high. The intensity is quite low. Right. I think I invite you all to go through that and see what is happening in the world. And I want to more specifically compare some of the parameters. Singapore and Sri Lanka. Out of 7 criteria, there are sub clauses. Look at the first. I'm highlighting a few one since we are limited in time. Expenditure on education, percentage of the GDP. In Singapore, 2.5. In Sri Lanka, we have 2. But we fight to 6% of GPD for education. It's not happening. Even myself is fighting for it, but that is not real. 2.5 in Singapore, 2 is in our, right? What is, look at the graduate in science and engineering. Out of all graduate, 36.3. In Sri Lanka, 24.1. This is where we can do certain improvement. Graduate in engineering and science. And third, gross expenditure on R&D. Look at the gross expenditure on R&D, research and development, as a percentage of DB, 2.2. In Sri Lanka, 0.1. You can see the difference. It is not just a graduate. Graduate, you don't see that big. See the big difference between the R&D expenditure by the governments. So if you identify the area where you can invest money for the research through industry-university collaborations, you can gain a lot. That is the contributions coming from that. So you know that equivalent expenditure on education and research more or less in equal phase in Singapore. But in Sri Lanka, they are two different. They separate each other very much. 0.1 out of 2.1. So this is where we should understand where to invest, how to get that output, how to govern the economy based on that. Some other facts. The knowledge intense employment, 59.5. In Sri Lanka, 21%, 21.7. Almost 1/3 of Singapore. Right. Then university industry RD collaborations. They are the score value 85. Sri Lanka 52. Not that bad. The research talent as a percentage in business, 54. We have 20. Now, that is why the universities are getting blamed that you have academics, right? The academics do research. They are on their research papers or in research articles or research documents, but they won't come out as a business. Your research does not go into the business. So this is where we can see how do you create all of these things are really important. And some of other parameters, patent, that and a citation document and all of these are there. And look at software expenditure and high-tech manufacturing. Compare them. And you can see what has happened to. Very interesting. See the software expenditure in Singapore, 0.2 out of the GDP. Sri Lanka, 0.5. What does it indicate? We don't develop the software. We hire the software. We hire the software. Why? Do you think that we don't have knowledge to create? No, we have. But there is no investment coming on to put that knowledge into a business. And these are very important, valuable documents. I don't know how many of the policymakers go through such document and first figure out these data are correct. But I have compared with the percentage of university graduate in engineering and science, and I verified some of the data before presenting to you. But see, these data are very important. Study this data and identify the system where you can implement. And finally, what I want to say, I want both academia and industry as a one unit. So what is the advantage of? We develop entrepreneurs in the academia as well as in the industry, right? They will feed the requirement in the academia as well as in the industry, right? As I said, the new development happening, and new development, you identify the new development, you create this knowledge through the research and through the industry collaboration with the universities. You create this knowledge and you invest for that, and you will create a good entrepreneurs. And those people will definitely funding you and make new development. This development definitely will contribute to our economic development. I invite you all to see this. Right? When you plan your future, when you plan your masters, when you plan your work, right? Thinking of the new generation, new development happening around the world, and accordingly, you go with your research work or postgraduate work. Right? Those are really important. Finally, what I want, the distribution change to this level. I'm happy before I'm retiring if I can contribute for this. Our undergraduate go to the 20% in local industry rather than 50%, and 20% go to the international construction industry. And I don't care about others going in the other field, but I want the international design firms and local firms that increment and going for a academia in local, academia in foreign, and having this sort of distribution. That we can bring a lot of knowledge into the country, new technology into country, and definitely that will help to develop the our industry with the adopting the new technology and what you call multidisciplinary engineering in practice. And also we can work in the global platform. Right, this is happening to a certain extent. Now, what we do in our undergraduate program, we let the first class guys to go out, and we develop a systems to retain the upper group at the industry as well as in our local academy. And we will give them the opportunity to work in MSc, PhD, or as a researcher. So we collaborate with the industry. We bring some of the industry burning problems, and we bring it and put in the research group, as I said, in a pyramid research. Not just one lecturer go and talk to the industry and get the project and do it. No, in the system, it is there. Right? Industry can come to a university, and university industry will collaborate, and that will assign to one research group, and they will sort the problem. And once they sort problem, the students who work on this project might require back to the industry, because he has solved a very specific problem. His knowledge will be very valuable in the industry. So he will be recruited by the company. So the new knowledge will be transferred to the industry. Likewise, this is happening in outside. Now, some of the first class guys who work in the Australian universities, and those Australian universities are getting a lot of funds from the industry for the industry-based projects, and they work on the industry. And once they complete their research work, the industry requires that knowledge, the industry is hiring those people. I have seen that, I know that many, throughout my career, I think I have many students, 20, 30 students has already been working on such project, and now they are recruited by the top Australian and American design firms as well as the construction firms. There are 30 or around 25 to 30 students are already working in this platform. Now I'm trying to interact with them, get the output, and how do I send more students and develop a network. But university system should support for that. Industry should support for that. Some of them might recruit it for industry, local industry. You can develop the new material development, SCADA systems development, or a drone technology development, or radar systems, signal processing, and all of these things. So we can brought all of these things back to our country. And finally, thank you for that. I think I took a little bit of more time. I'm sorry for that, as usual. And I must thank, and I put some photos to remind you some of the scenic beauty at Peradini. Thank you very much.
Thank you, Professor. I am one of these undergraduates, started in 1971 using the A course and B course. And the B course subjects are taught by mostly the visiting lecturers, like Dr. Balasurya. There's one engineer from Water Board. I studied the geotechnical separate subject, and public health engineering, structural engineering separate subject, then project management done by one of the leading engineer architect, then irrigation. Actually, really we had lecture during the afternoon session. Project management is done by one of the architects. Actually, his lecture is about 2 hours or 2.5 hours. He finishes about 3 packets of cigarettes. And normally we call this construction management, we call conchat. So yes, he give a conchat. Actually, we started the batch about 25 students using this subject. Finally, only 2 did the examination in construction management at that time. So actually, there's another opportunity, because if we pass the B course subjects with the A course subject, we even just passing, we can get the 3rd class honors. So that facility also there. So most of the students, they did A course and B course, other than few who did only complete the A course. Actually, Professor, it's a very informative lecture. Actually, I thought of step down from the, the managing director of my company because we are too old to gather most of this what you have explained. Anyway, very informative lecture. Actually, it's very good for young engineers. So I call all the participants, if you can, if you have any questions, to raise from Professor and to clarify whatever doubts you have.
Yeah, I think Professor Kushan, it's a very informative lecture. Something I noticed in your presentation is about what exactly Engineer Ananda Senath was speaking. The elective course, in fact, we also did the same process. It was done by industry expert. For example, industrial trade, industrial evolution, something that was done by Mr. D. Mendis. We can still remember what he was taught and we still apply it. So at DICB meetings, also we are repeatedly requesting to get industrial expert for these elective courses. We are not asking the industry to go and teach finite element methods, but there are areas where the industry can teach the students because still, unfortunately, the students are not aware of the industry. So recently, I had to interview one. I thought I will interview some Peradenian students, take them as structural engineer. They say they are very interested about doing structures and all. I asked to name few major projects in Sri Lanka. I said it could be billion, it could be hydropower. They could not name even single project. I said, have you heard about Altair or whatever the high-rise building? They are not aware of the high-rise buildings which has constructed in Sri Lanka. So this is because I think the collaboration with the industry is very less. So we are repeatedly requesting the industry, the universities to get industry expert for some elective courses. They know harm because if you don't know, you can skip that. And as well as getting the industry to consult the universities for the industrial technical problems, find solutions. I think, as you said, it should happen. Still, there's a big gap between the industry and academia. The universities will have to start on that so that the industry also will get, connected. Thank you.
Just to add a few things. That is why I highlighted for a young generation. I would say not a young generations, I think mid-career generation. I think if you collaborate with the universities and industry, and we can get a lot of achievements. Unfortunately, this is happening not in a systematic way. I think industry has no way to approach to the university, and university haven't created the systems to approach the industry. And industry also should be able to see that if there is any problem and within your capacity be sorted out, you should not come to a university. And you should solve it in your capacity. But if there are things you can collaborate with the industry, you should open the mind and come up through the system. And rather than going for individuals. When it go for the individuals, what happened? That relationship be end up with that individuals. It won't spread to the people and to the community. I mean, this is where we need the systematic approach at the university level as well as at the industry level to set up the industry-university collaborations. What I see that the master program, and as you said, the teaching in undergraduate and postgraduate both, there should be a certain opportunity for the industry to come and deliver their expertise, among the community. Yes, we need to have that setup.
Thank you very much, Dr. Kushan. Thank you very much for your very informative and very, some things are very controversial, but I think there is a truth behind that, but we want to convey to the audience. I agree on most of the things what we have stated here. And very first, I want to tell something. But when you compare about the international scenario and Sri Lankan scenario, we have a very different approaches. Now, but government wants to produce as much as undergraduate, and they don't think how they will be used for the development of the country. And what they do, what happened after that, it's all up to the individual, and the cream goes to the country. Even they don't come back, at least the percentage will not come back to contribute their knowledge in Sri Lanka. And that was, I mean, if you take for 10, 15, not 20, 30 years, it was not the case. And also, we can't blame them also because of the situation of the country, and there is frustration because of the certain reasons, and that affects directly on universities. And also, I think the fund allocation and your resource, especially the lecturers. We have at the moment, I think most of universities run at a very low level of that, and that also affects the quality of the higher studies. When you talk about industry and university collaboration, that is also a very good thing. But the thing is, there are so many barriers. You can't implement it. As Nandana stated that we need certain percentage of input, especially the courses like engineering, some industrial contribution. I think when we were in the Peradeniya University, we had little bit. But nowadays, I don't know up to what level. Maybe people are, maybe, I don't say industry people are not very keen to go and do the lectures. They might, not for the money, but for other reasons. But it is not really harvested, I think. And that also reflect in the, I mean, the undergraduate who passed out from the university. And also you directly stated very controversially that part-time courses will not give that much of benefit. I mean, if you go to any other countries, they may have part-time, but they have full-time. I mean, if you go to, I recently went to IIT Roorkee, they have in civil engineering department, they have 500 PhD students. PhD. Exactly. And they were given some government support, but not that attractive. But still, they were in those cells and they contribute. Their PhD courses are about 3-4 years, more than 3 years, sometimes 4 to 5 years. And we don't have that kind of system. Yeah. And we want to, I think even the universities want to make more postgraduate diploma or degrees. Maybe you know the obvious reason for that. And we may not have the resources also. I mean, I don't completely, I mean, the frame universities. But I remember in Peradeniya, we had MPhil courses some time back, and not much of people, but at least a small number of people engaged on those things. I think we had that, you are quite correctly told that. I mean, that is the way we have to move forward. We want to develop our industry in Sri Lanka. Yes. And also, as you said, in terms of the businessman, I totally agree with what you have stated here. And I thank you very much again. I mean, for the thought-provoking lecture you did. And
thank you. And very quickly, I must say that why I said the full-time master program. I am not, I mean, in the Peradeniya now, our plan is not to just recruit the local students, inviting foreign students to join our master program, at least in South Asian region, because you don't know, in India, if you look at all IITs cannot cater the demand in India itself. Why can't we deliver the, at least, I'm not saying it the exact level of IITs, but the closer level to the IIT degree program in Peradeniya? Why don't we attract Indian students to our university system? No, that develop the, collaborations. Some of the Indian or South Asian or North African students, I mean, they will be in our systems and they might collaborate with us the way for the various projects outside Sri Lanka. because they know that the capacity of our level, our industry. So then we can spread our knowledge, our system awareness among the other community outside Sri Lanka. That is very important. That is where we have to go out. And collaborations. You can say how many research collaborations we can make with the foreign universities, and we can bring a lot of money through that into our systems. We don't need to blame that we are not getting money from the government every year, but we should put certain effort to develop this industry university research culture and bring collaborative research fund to the university. So there are various approaches.
May I add one more thing? When I was in India, there were two professors who came who and they said there is a fund, there is a separate fund given by the Indian government to have the joint research program
Exactly.
with Sri Lanka. But there is not much of interest from our side.
Yeah.
And when I came here and discussed with various academic personnel in Sri Lanka, but what they said was the assistance given by them are not very attractive. They compare with any developed country like USA or
The networking is important.
yeah, and that is but it is still the funds are available. And the only thing is people need to move actually.
And
But it can be not utilized.
yes,
That's what they say.
At Peradeniya, we are having a RMIT University of Peradeniya split PhD program. I think we have enhanced our research culture massively in last 5 years. Now we are having around more than 61 Q1 journal publication at the department. It means that our lecturer produce 2 quality journals per year. So we have developed now we have the environment, we have developed the research culture. Now what we want to looking for, put that research into the business, as I mentioned. So we have to have a certain steps for that. Sorry. Please.
Can I see the, yeah. Can I see that comparison between Sri Lanka and Singapore? Because there it shows both Singapore is 2.5, Sri Lanka is 2, but the government of Sri Lanka won't spend a lot, I think. That's government funding pupils secondary, that is 20 in Singapore, 6.3 in Sri Lanka. It has been going on for about 50 years now. It's very low. And also Sri Lanka GDP is also low. So it has been massive amount, I think, low. Yeah. Compared to India also, because if the government is not funding, the problem is there will be less competitiveness in education institutions, and then the quality of the students will be poor because parent funded students will be lot. So that will be a big problem in Sri Lanka now, because it's very difficult to go to university with the advanced level, very competitive, because positions are less, government positions are very less. It has become increase in India. They have NEET, PG, NEET, like that exams where the merit positions are even for the officially private universities. There's a merit order list. Indian government has started. That's also there.
Yeah, I mean, what I brought this all data to you just to analyze what is happening in the country at the moment. I mean, you and me looking at these data is nothing happened, but at least we get certain awareness. But policymakers, the policymakers should look at. Now the question is coming, okay, if you fund this much to education, and we have to have a priority list, our investment, and then we have to look at the outcome. I mean, the funding continuation to the certain project based on the outcomes, right? I mean, as many of you said before, right? Producing many engineering and science graduate won't work itself. But we have to have a systems to incorporate them. Now, for example, we produce 2,500 engineers. Obvious question is, our local industries too small to cater that number. But what is our government policy? How do you cater the additional demand, additional production? What will do? What is the policy we have? And how then the government should be able to promote our industries to go out, have you seen, I think you are representing industry. What is the support from the government to go out from Sri Lanka? You know, how many projects going in Saudi Arabia? For example, I will take one example. How many projects going in Saudi Arabia? And we have a government network with the Saudi Arabia. There's an official communication. And what is our government, the steps taken by the government to promote their companies to come to the Sri Lanka and have a discussion with our industry and see that what are the possibilities of our industries go and plant there or take a part of the project. I mean, government interference is so important. And looking at the aspects, if you don't produce this much and it is enough for our country's development, we don't need to go out. But we see, obviously, we have to go out from this country. So then we have to have a certain mechanism. That is why I'm saying the systems and a broader perspective, overall system is really required at this moment. But if you just say one term out and pop up it up, and it won't work.
Another thing is when you are saying the cream of the educated in Sri Lanka's case, because of the educated people are more and economic development are less, we can't keep that cream of people in Sri Lanka because too much, as you earlier said, you told earlier at the beginning, they have to go abroad and work because Sri Lanka is not developed, economically not developed, but because of welfare schemes, Sri Lanka has more educated groups. So even parents given education, government also responsibility, but a lot of parents are educating, so they have it's natural for them to go and work in abroad. That stream of the that
cream of the country is
that the idea won't work in Sri Lanka at this position, at this time.
Yeah, I mean, at this moment, we are facing a big trouble. I think we all aware of it. But I mean, we are not sustained in this low level for a longer period. But now we are in the process of making changes. So what I'm saying that when you set up a system for the new generations with the economic plan, I mean, we have to look at all of these things and have a proper systems to be established. And through especially the university research collaboration, this is where we can make use of the cream of the country for something so effective. But what happened at the moment, since our university and industry working separately, the most of the people who join the university with the potential, they might say that I can't do anything. I want to do the research, but I have nothing. But meantime, if you set up a systems, such people can collaborate with the top universities around the world, and probably they might, somebody has already done a PhD at Cambridge, and he returned back to Sri Lanka. And we have a set up of systems. Okay, he can do the collaborative research with the Cambridge continuous, and he will retain in Sri Lanka. And the collaboration outcome coming back to the Sri Lanka. Like what I'm saying that we don't have a systems to have a collaboration. I'm not saying that industry is local. We have to even approach the international industry. The international industry, university collaboration. Local industry, university collaboration. This is so important at the moment to keep the cream of the country in the country. Otherwise, this will leave. And what is happening now? Mid-career group is already leaving the country. And the experienced engineers is leaving the country. What happened? The newcomers, new graduates come into the industry. Nobody will guide them. They have the knowledge. They don't have the exposure to the industry. So then they can go here and there. There is no proper guidance because we have a serious issue now. Now, how do we address those issues? Our relevant authority should take certain steps. Why not? I don't know. I mean, I brought this up. We need to create the environment required for good people to keep the country. I mean, that is not only the economic matters. We need to have attitude change as well. We had too much discussion, I guess, now. We are waiting for that. The most important gossip part be very useful.
Thank you, Professor, and the audience. I think you may have cleared all the doubts we have. And as the last item, I invite our EXCO member, Engineer Anurudh Singh, who organized the event for this question time this month, to deliver the vote of thanks.
Thank you, President. Now we have come to the end of a very exciting and very timely relevant presentation made by Professor Kushan Vijayasundar. Now it is time to pay our gratitude to Professor Kushan, and there is a small token of appreciation which will be granted by Tokyo Cement. I kindly invite Professor Kushan to come to the stage, and also to President Mr. Ananda Senarath and Mr. Janaka Pereira, who is the consultant to Tokyo Cement, to grant the token of appreciation. Right. So now I have to deliver the vote of thank. Right. So all of us know Professor Kushan Vijayasundara as an expert in the field of computer modeling of structures, seismic engineering, structural dynamics, and advanced structural analysis. So when I called Professor Kushan, and when I invite him to make a presentation for the March question time, so he accepted the request. And then I asked Professor Kushan whether he can deliver a presentation on with this expert the areas. So then what Professor Kushan suggested me is no. Now we should deliver a timely, relevant kind of a presentation. So therefore, he suggested this the topic, right? And thank you, Professor Kushan, for enlightening us on this structural engineering education and new technologies available and challenges facing by the young and structural engineers, and how the structural engineers can become entrepreneurs. So thank you, Professor Kushan. So I grant my sincere gratitude to Professor Kushan for coming all the way from Peradeniya to Colombo, and for delivering this excellent presentation. Thank you, Dr. Kushan. Then I should thank our sole sponsor, Tokyo Cement, for sponsoring this QT event. We know that the Tokyo Cement is very concerned about continuous professional development of the engineers. So that is why they wanted to sponsor most of the question time event in this year. So thank you so much. I would like to thank Mrs. Buddhika and Mr. Janaka Pereira for the kind contribution. Then also I would like to thank the President and the Executive Committee of the Society of Structural Engineers for the support they have granted when I organized this event. So when Professor Kushan sent me the topic and the abstract, I have a discussion with our President, Mr. Ananda Senarath, and he was very delighted with the abstract, and he asked me, granted his permission to proceed with the presentation. Then I would like to thank Institution of Engineers Sri Lanka for providing their auditorium and also the members lounge for the Hopper night. Then I would like to thank Mr. Yoga Prajapan and the Associate Chapter of Society of Structural Engineers, the grant for granting their help for this event. Then I would like to thank the staff of the Society of Structural Engineers Secretariat, who gave their full support for this event. Last but not least, I would like to thank all of you for participating this presentation in the middle of your busy schedule. Thank you so much. And this Hopper night is ready at the members lounge at the ground floor. So please enjoy the night. Thank you.